Welcome back. The law of conservation of mass. So this law is proposed by Antony Lavoisier in the middle of the 17th century. According to this, in an all physical and chemical changes, the total mass of the reactant is equal to the product. During a chemical change, the mass neither be created nor be destroyed. Take an example. So this is a calcium carbonate, CaCO3. When it is heated very strongly, it is split up into calcium oxide and carbon dioxide. The mass of the calcium carbonate at the reactant side is 100 grams if it is a 1 mole. I am producing 1 mole of the calcium oxide and 1 mole of carbon dioxide. Therefore, the mass of the calcium oxide is 56 and the mass of carbon dioxide is 44 grams. The sum of the product, if you analyze, it will be 100. Therefore, the mass at the reactant side and the mass at the product side are equal. That is, in all physical and chemical changes, the total mass of the reactant is equal to that of the product. That is the law of conservation of mass. Second law, that is law of definite proportion, and this law is proposed by Joseph Proust. A pure chemical compound is always consists of same elements combined together in a fixed ratio by their weight. So here, taking an example, carbon dioxide can be prepared or produced by two methods. One, direct burning the carbon in presence of oxygen, you get a carbon dioxide. Another way, when you heat the calcium carbonate strongly, you will get a carbon dioxide. In both the case, 12 gram of carbon is reacting with or combining with 32 gram of oxygen. Therefore, both the case, the 12 gram carbon combining with 32 gram of oxygen. Therefore, the proportion we can write here in the ratios, that is 12 gram of carbon combining with 32 gram of oxygen. Therefore, the combining simplest whole number ratio is 3:8 for the carbon dioxide. This law is not applicable for the isotopes, and also it is not applicable for the isomers. Here we are going to discuss the law of multiple proportion. Note it, two elements combine to form more than one product. Then the weight of one of which is combined with the fixed weight of the other bears simple whole number ratio. We take an example here. When hydrogen and oxygen combines, there are two possible products. One is water, another one is hydrogen peroxide. In the water and in the hydrogen peroxide, the 2 gram of hydrogen is constant. And with that, the combining the oxygen with having a different masses. In water, it is 16 gram, whereas in the hydrogen peroxide, it is 32 gram. Therefore, the two elements combine to form more than one compound. Then the weight of one which combined with the fixed weight of the other bear a simple whole number ratio. So therefore, combining ratio of the oxygen in both the product, that is, we can write here for H2O divided by H2O2. So here in the H2O, the oxygen having 16 gram, whereas in the peroxide we have it is 32 grams. Therefore, the fixed ratio is 1:2. If two elements form several compounds, the varying composition, then this law fails. For example, if this is a interstitial compounds, in that case, this law fails.